The first paper I want to discuss today thinks about advertising measurement and assessing whether digital ads, it's going to be ads placed on Facebook, whether they generate kind of additional purchases, views, and so on. This is a paper by Brett Gordon and co-authors. The main focus of the paper is thinking about the causal effects of digital ads. So does having that ad there on your Facebook feed generate sales, as opposed to if it wasn't there and there was something else? So the specific questions they want to go after is, what is the effect? So how large might the effect of that digital advertising on your Facebook feed be? And they're also going to, throughout the paper, think about if they couldn't do this within an experiment. And I actually find this to be really interesting. If they couldn't do this with an experiment and they had to rely on observational data, could they have reliably estimated the causal effect of digital ads, right? So there's different approaches of thinking about if you didn't have an RCT, how you might go about it. In the paper, they delve into those in great detail. And they think about, okay, the RCT, the kind of diff and diff kind of idea, is kind of the gold standard. If I didn't have access to that and I had to do something else, how close to that gold standard estimate am I going to be? The way they're going to do all of this is they're having access to large scale experiments. I mean, 15 large experiments at Facebook. And this data is just super cool, right? So if you read in the paper, they disclose that, obviously this data is not that easy to get. There's Facebook co-authors on the paper because they're using Facebook data. These guys had to be notionally employed at Facebook to be able to get access to it, et cetera. So this is really cool data to be able to work with, but it's generally not going to be accessible to someone like us as researchers or other people potentially trying to process the effects of Facebook ads. So I think it's a really interesting insight to how much power or how much data really you need to be able to estimate the effects of these digital ads. And if you didn't have access to all that kind of Facebook power in terms of what they have and what they can do with experimentation, what chance do you have at trying to recover a effect of your digital ads? So the way they're going to think about this, just for people who don't use Facebook every day, you have a news feed, right? Information that your friends are posting, and then you get served an ad like after so many pieces of information of your friends. And it's those ads that we're interested in. Those ads appear both in the middle of your feed, down the side, on the mobile phone as you scroll through. And the challenges are going to be that if you're an advertiser and you're placing this ad, right, how did you get to serve that ad to somebody? Well, first you choose a demographic, right? Like, I want to place an ad. I want to target men age 24 to 35, and so on. So then what they're going to do in the paper is they're going to use the demographic, that's who you're targeting. But then among those people, those potential people that I could serve the ad to, some of them are going to be my control group, some of them are going to be my treatment group. I'm going to give some people the ad, some people not, and then look at the differences. So what they do, I think, really well in this paper is carefully explain all the kind of wrinkles that kind of lie in digital ads on social media platforms or digital advertising more generally, and kind of point out that there's a lot of endogeneity out there, which is going to bias kind of traditional estimates. I kind of explain what it is, why it might be there, and so on. And the reason they're worried about this is the idea of selection bias. And why do we care about selection bias? Going back to an earlier lecture, I forget exactly what number, we talked about, when you have selection bias, the idea of kind of selection on observables, that your OLS estimator is going to be biased and not give you a causal effect. So the three sources of endogeneity that they talk about are user-induced endogeneity, so the idea of activity bias, So for me to be exposed to the ad, I had to have actively been on Facebook during the campaign period that the ad was running. And that's an endogeneity problem. Not ever, like there's no randomization into who's active on Facebook per se. I made a decision to go on Facebook today. There's going to be target induced endogeneity. And we don't have an RCT, this is going to be quite a problem. In that when you're saying I want to hit males aged 24 to 35, I think I said before, as you try and serve your ad to people, these modern delivery systems and how ads are kind of allocated are going to optimize kind of the criteria and who they show the ad to. So they're going to compete in auction or kind of target who they're going to target exactly within that age group, because there's different things that you can kind of sub-target on. Think of it that way. The ad delivery system looks at how it's performing. So it looks at how your ad's performing and might make adjustments. There's also going to be competition-induced endogeneity. And the idea is going to be to, as an ad campaign, to be able to display the ad to the user. The reason you got to display the ad is you won an auction that ran really quickly before the ad was served. And then if you won the auction, right, so you were the ad that got to get served because you paid the most, that means that the user who sees the ad is highly valued by you as an ad campaign. Most likely because you have a higher expected conversion probability, right? You won the auction because you think that guy is going to be valuable to you. Why is he going to be valuable to you? Well, I guess you think that there might be something the ad does to him that makes him click through to your site, sign up, view the page, buy something, etc. These three sources of endogeneity kind of should suggest that if you don't have the field experiment trying to estimate the causal effect of an ad, you're going to be plagued by these three things. And trying to back out a causal effect with some kind of other method, it's going to be extremely tough. So in the paper, what they're going to do is they're going to try and measure something. So you can kind of come up with a common metric. And what they're going to measure, and they're going to measure two things. They're going to measure the intent to treat effect, what they're going to call ITT. And that's going to work nicely for their RCT, for their experiment. But when they go outside the experiment and try and use observational methods, that's going to be hard to work with. So they're also going to compute the average treatment effect on the treated, which is what I'm going to think about today. So it's the effect of the ad on a user who's exposed to it. And what they're going to measure is something called lift. They call tau L. And it's going to be defined as the change in the conversion rate due to the ad in the treatment group. So the change in the conversion rate being change in checking out an item, viewing a page, or registering, divided by the conversion rate of the treated group if I had not been treated, right? So the idea of a counterfactual. If I hadn't got treated, what would my conversion rate be? So the ratio of that change relative to what would have happened if I didn't get treated, it's going to be their measure of lift that they want to use as their metric throughout the paper. So the 15 experiments they run are relatively large scale field experiments. If you look at the data, they're all in terms of millions of observations of different ad campaigns, generally across e-commerce, retail, and tech. The size of these experiments in terms of observations runs from around 2 million up to over 140 million observations. It's just huge. It's going to be a test group. It's going to be a control group. The ratio of test to control is going to vary over experiments. It's not going to matter too much. And then there's going to be impressions. So how many people saw the ad? Clicks. How many people clicked on the ad? Conversions. So did people do what we wanted to happen as the ad campaign, which is going to be one of three things. C for checkout. So did you buy something? R for registration. Did you sign up for something? P for page view. Did you view the web page that they wanted you to click through to? So the RCT results are going to be presented. So this is the experiment. We do some kind of diff and diff idea. And in the paper, they kind of, again, show you that diff and diff table and how you would compute this. Thinking back to what we did in a previous lecture, similar idea. They're going to compute the average treatment effect on the treated in table 4. And then they're going to compute lift. And what we see here is a few things. So let me get a pen out again so I can draw a little with my kind of shaky pen. So the first thing we're going to see, if we look at checkout, so like these first 15, okay, so all 15 studies care at least somewhat about checkout, so buying something. And we see that there's, if they're in bold, it's significant at the 95%, sorry, the 5% level. And we see that there's 1, 2, 3, 4, 5, if I got my math correct. Yeah, 5 of those effects are not significant. So not every ad generates statistically significant effects on checkout. And the effects, they vary quite a lot, right? It goes from like almost 450% effect of the ad here, down to like 1% and statistically significant. So in terms of checkout, in terms of conversion to buying something, we see that there's a lot of heterogeneity and it's not always statistically significant. If we look at registration, again, we rely on these RCT estimates. What do we see? We see that 4 out of 5 statistically significant, and they're relatively large effects on average compared to checkout. So registering is obviously less costly to a consumer because you're not spending money, you're just signing up for something. And we see that there's a fact, we do find effects on that. And we find effects on page views for the 3 experiments that served. And we're interested in tracking page views. Okay, so randomized control trial, field experiment, diff and diff style estimator. We find effects. Let me rub out those bits of blue that I drew on the page and flick to the next slide. So then what they did is they said, okay, diff and diff, gold standard. We know we can recover causal effects when we have field experiment and kind of a diff and diff style setup. What if we didn't have access to that and we tried to do a wide range of other estimates, right? So what they're going to do in this table, it's hard to read. It's hard to read in the paper as well, but you can zoom in and really see what's going on. They're going to measure, we're going to try and recover causal effects using a whole bunch of different estimates going across the table on each of the metrics for the 15 experiments that were tracked. And what they do is they shade in this table kind of how good or bad the alternative estimators, the observational methods that don't rely on the experiment do. They're trying to recover a causal effect. What you find here, if you just look at the table, there's a lot of red, right? Like lots of red. And what does red mean here? Red means you overestimate the effect of ads. So you see that there's a lot of overestimating the returns to advertising when you don't do the experimental idea with a diff and diff. Point 1. Then what you see is that there's various shades of red, right? And in the paper they say, okay, darker red, bigger bias in your estimate. So the worse you've done in terms of overestimating the effect. See, there's a lot of dark red in the table. And I think being really dark red tells you something like you're 3 times over the treatment effect. Your estimate is 3 times bigger than the treatment effect estimated from the RCT. That's huge, right? You're overestimating something by 3 times. So a tail takeaway from this figure, and when you read the paper as well, I think more generally, we think about trying to measure the returns to digital ads and social media sites or websites more generally. If you don't have access to an experiment, you're between a rock and a hard place trying to capture kind of an accurate estimate of the effect of your advertising. So the main takeaways from this paper, having read through it and having talked about it now, is that your RCT, your randomized control trial, your field experiment, or your actual experiment is going to be a gold standard way of being able to measure advertising effectiveness. And when you do it, what you find is really heterogeneous effects, right? So they find insignificant differences for checkout conversion in 5, not 6, of the 15 experiments. And you also find that there's significant effects almost always for registration and page views. So ads, relatively effective at generating views and registrations, effective at generating checkout and kind of sales conversions, but less effective than other metrics. And that makes sense because buying something is much further down a purchase funnel. So you'd expect that they're not going to be maybe as effective at getting you the whole way into purchasing. The second takeaway from the paper for me, hopefully for you, is that these observational ideas, trying to capture the effect of digital ads with observational methods, it's going to be tough. You're going to overestimate the effect. You're going to overestimate that lift of your digital ad on whatever metric you care about. And you can be wrong by a factor of up to 3. So you can get it wrong by a factor of 3 times. And generally, you're overestimating. If you're underestimating an effect, maybe we're less worried, right? It's like, okay, you're just hitting a lower estimate. When you're overestimating, you drastically shooting way too high the effect of your digital ad. That's tough, right? You might, if you try and use these other observational methods in kind of measure the effectiveness of your ad, you're overestimating the effect of digital ads, and maybe you're throwing more money than needed at these things. What I find actually as well, if you read through the paper, and I don't want to belabor the point too much because I'm not sold on it per se, is that the observational models, so not doing the diff and diff style thing, is better for registrations and page views than for purchase conversions. I'm not really sure what to make of it, but they show that it seems to be better. So that's the 2 main takeaways. If you want to measure digital ad effectiveness, they're kind of the same. Use RCTs, right? Or try and run some kind of experiment to see the effect you're getting. Your observational measurement is going to get it wrong, and it's potentially going to get it wrong by a really large number. So that's going to be bad because you're going to be overestimating the returns of your advertising.